Imagine this. A team of scientists is drilling deep into the Antarctic ice sheet, a place untouched by human hands for millions of years. Their drill, pulling up cores of ancient ice, suddenly hits something unexpected. It is not rock. It is something hard, something smooth, something manufactured. With great care, they bring the fragment to the surface. It is a shard of a material unlike any known alloy, impossibly light yet stronger than diamond. Etched onto its surface are patterns, not random scratches from geological pressure, but a deliberate, intricate design that speaks of intelligence, of art, of a mind at work. This is not a meteorite, it is a relic. The implications of such a discovery would be staggering, sending ripples through every field of human knowledge. It would force us to confront a profound and unsettling question. Are we truly the first intelligent, tool-making beings to call this planet home? For centuries, our story has been one of a linear progression from simple organisms crawling in the primordial soup to the complex societies we have built today. We have always seen ourselves as the pinnacle of Earth's evolutionary journey, the sole authors of technology and civilization on this world. But what if our story is just one chapter in a much, much longer book? What if there were others before us? This single, impossible artifact pulled from the frozen depths would rewrite our entire history. It would suggest that long before our ancestors painted on cave walls or forged their first metal tools, another civilization rose and perhaps fell. A civilization so ancient that all its cities, its monuments, and its people have been erased by the relentless churn of time, ground to dust by shifting continents and buried beneath miles of rock and ice. All that remains is this one tiny fragment, a ghost whispering of a world that existed in an epoch we can barely comprehend. Our planet is truly ancient. It is a quiet, patient world. It has been spinning through space for around 4.5 billion years. Imagine the entire history of Earth compressed into a single calendar year. On this calendar, the first simple, single-celled life forms do not appear until late March. The dinosaurs, those magnificent creatures, only arrive in mid-December. They are gone by Christmas evening. The entire recorded history of humankind, from the ancient Egyptians to the present day, would flash by in the final few seconds before midnight on New Year's Eve. This vast, deep time provides more than enough opportunity for entire sagas of life. We tend to think of history in thousands of years. The geological record speaks in millions and hundreds of millions. Continents have drifted apart. They have crashed together. Mountain ranges have risen up. Those mountains have been eroded into dust. Immense ice ages have advanced, and they have retreated. The planet's surface is not a static museum. It is a dynamic, constantly recycling system. This fascinating idea has a name, coined by scientists Adam Frank and Gavin Schmidt. They call it the Silurian hypothesis. The name is a playful nod to a classic sci-fi TV episode. It featured an ancient, intelligent reptilian species called the Silurians who existed on Earth long before humans. The hypothesis is a serious thought experiment. If an industrial civilization like our own had existed millions of years ago, what kind of evidence would it leave behind that we could actually find today? It forces us to think beyond finding a simple fossil or a buried city, both incredibly unlikely to survive. Direct evidence like buildings or tools would be long gone. Instead, look for indirect planetary-scale signatures. It consumes vast amounts of energy, digs up resources, produces waste. These activities would leave a faint but detectable chemical fingerprint in the geological layers. Think of our own time, called the Anthropocene, the age of humans. We are changing the chemistry of the atmosphere and the oceans. This change will be visible in the rock record for millions of years. What would these fingerprints look like? A sudden spike in carbon isotopes in sediment layers from burning fossil fuels. The story of life on Earth may not have even begun on Earth. There is a captivating hypothesis known as Panspermia, which proposes that life in its most basic form is not unique to our planet. Instead, it suggests that microscopic life forms such as bacteria or other hardy microbes can travel through space, hitching a ride on meteorites, asteroids, comets. These tiny travelers, protected from the harshness of space within the rocky confines of their cosmic vehicles, could then seed life on any hospitable planet they crash into. Life, in this view, is a cosmic phenomenon, drifting between the stars. This idea is not as far-fetched as it might sound. We know that some microbes are incredibly resilient. They can survive extreme cold, intense radiation, and the vacuum of space for extended periods. Scientists have found microbes thriving in the most inhospitable places on Earth, volcanic vents deep in the ocean, dry, frozen valleys of Antarctica. We also know rocks are exchanged between planets. A large impact on Mars could eject rocks from its surface, sending them toward Earth. If we are to search for a lost civilization, we must, well, understand what we are looking for. The chances of finding a fossilized skyscraper are virtually zero. So what clues could possibly survive across tens or even hundreds of millions of years? The most promising evidence would be chemical, not physical. An industrial civilization would require immense energy. The most likely source for that energy would be fossil fuels. Coal, oil, gas. Burning. Those fuels releases huge amounts of carbon into the atmosphere, changing its isotopic signature. That change is recorded in the shells of tiny marine organisms. Those shells settle and become part of the sedimentary rock record. Beyond carbon, we could look for other chemical anomalies. Massive fertilizer production would alter the global nitrogen cycle. That alteration would leave a distinct signature in the sediments. Synthetic materials that do not exist in nature would be a powerful clue. Imagine finding a thin, ancient rock layer with complex chlorinated molecules. Imagine finding microscopic remnants of plastic-like polymers. Cross-section of the ocean floor showing layers of sediment with one thin, dark layer highlighted. While large structures are unlikely to survive, the fossil record itself might hold subtle clues. You know, the process of fossilization is actually pretty rare and kind of haphazard. However, if a civilization existed for thousands of years, with a population in the billions, it's at least conceivable that a few individuals might have been fossilized. The real challenge would be recognizing them as intelligent beings. We often assume an advanced species would look something like us, but evolution could take many different paths. Imagine an intelligent octopus-like creature. Beyond fossils of the beings themselves, we might look for what paleontologists call trace fossils, not the organism itself, but evidence of its activity. We actually find fossilized footprints. We find burrows. We find nests. But what would the trace fossil of an industrial civilization look like? Maybe we'd find evidence of ancient mining operations, large, unnaturally shaped excavations in geological strata. One of the most defining materials of our own civilization is plastic. It's everywhere. It's in our homes, our cars, our clothes, and unfortunately in our oceans and our soil. Plastic is a synthetic polymer, a material that just doesn't exist in nature. Because of its ubiquity and persistence, future geologists will almost certainly find a plastic layer in the rock record that marks our era. This layer, filled with microplastic particles, will be a clear and unambiguous sign of our industrial presence on this planet. When we consider the possibility of lost worlds, we really shouldn't limit our thinking to Earth alone. Our solar system contains other planets that may have once been habitable. Mars, our rusty neighbor, is chief among them. Today, it's a cold, dry desert with a thin atmosphere. But evidence from rovers and orbiters tells us a different story. Billions of years ago, Mars had lakes, rivers, possibly even a shallow ocean. If an advanced civilization ever existed on Mars, finding its traces might in some ways be easier than on Earth. Mars doesn't have active plate tectonics like our planet. Its surface is much older and more static. While wind erosion and dust storms have reshaped its landscape, they're just not as destructive as the constant geological recycling on Earth. A city built on Mars 300 million years ago would be buried under dust, not subducted into the planet's mantle. The ruins of a Martian civilization could still be there, waiting beneath the red sand for a future robotic explorer to uncover them, waiting beneath the red sand for a future human explorer to uncover them. Venus is another intriguing, though more challenging case. Today, its surface is a vision of hell, with crushing pressure and temperatures hot enough to melt lead. But some models suggest Venus too might have been habitable for a long period in its distant past, with liquid water oceans before a runaway greenhouse effect took hold. Any evidence of a past civilization on its surface would have been obliterated by this catastrophic climate change. However, maybe some clues could remain in the more stable upper layers of its atmosphere, which is a target for future scientific missions. The stories of Mars and Venus serve as planetary parables. So, we must ask the final question: what would it mean? What would change for humanity if we found definitive, irrefutable proof of a lost, advanced civilization on Earth? The discovery would be the most profound in human history, fundamentally reshaping our understanding of ourselves and our place in the universe. Our entire sense of identity is built on the idea that we are unique, that we are Earth's first and only technological species. To learn that we are not the first but merely the latest would be a deeply humbling experience. It would shatter our species' perceived specialness. The discovery would force us to confront our own future with a new and urgent perspective. We would immediately want to know what happened to them. Did they succumb to climate change of their own making? Did they exhaust their planet's resources? Did they destroy themselves in a global conflict? Their story would become a cautionary tale of immense power. Their fate, written in the rock record, would serve as a stark warning, showing us a potential path that our own civilization could follow. We would no longer be guessing about long-term existential risks. We would have a case study. On a deeper philosophical level, it might also bring a strange sense of connection. To know that we are not alone in our experience of building, creating, and wondering would be profound. It would mean that the emergence of intelligence and technology is not a freak accident, but perhaps a recurring feature of life on a habitable planet. We would feel a kinship with these lost people, a shared identity as children of Earth. Our planet's history would become richer, deeper, and more mysterious. We would be the inheritors of a world that has known intelligence before. Ultimately, the search for a past civilization is also a search for ourselves. It forces us to look at our own impact on the planet, to consider our long-term legacy, and to wonder what traces we will leave behind for the eons to come. Will our story be one of a species that learned from the past, or will we become another thin, anomalous layer in the rock? A brief, bright flash of activity that eventually faded into silence? The Earth holds its secrets close, but by searching for others, we may, in the end, learn the most about ourselves.